就开着啊，就是有讲话的。
哎，我想说，对啊，没有问题。
前面会剪掉的。
就我现在真的，
对啊，
然后刚才还没挂的时候，
但是
还没出现。
不是哪一个的？
哦，这里已经出现完了。到你。
我们讲 define 这个东西啊，不 define。
define 都是新个 variable 嘛。
我没有 define 过 multiple 的，这么神奇
multiple 的话就是连着 combination of x y 嘛。
啊？为什么没有？不是漏掉吗？
define 过吗？我不记得有 define 过。哪一个？两个 variable 的 formula。你是写那个？
我没有 define 过，
没有啊。
很夸张，不是找看。
我想不开。
哎，这个东西，
你后面上传的那个扩圈人1、2、3是去年的吧？
对，
是加和乘嘛？
我没有 define 过那种 Adjoining x1 x2
啊，你们在说什么？
那里面还有 define 过 multi-variable 的 polynomial general form
好像有吧？
在哪里？
有吗？我不知道，
也没有印象去。
我也是没有印象。
在哪里？
在哪里？
就是那个 RxEx啊。
对了，
有肯定有啊，他不是都讲了吗？他都讲怎么说的呀？
哦，这里。
对啊。
哦，我是这样 define 的。虽然是有一点点差别啦，但是就
什么差别
啊？
什么差别？
那个
就是跟什么有差别？
虽然是有一点点差别啊，你懂这个什么意思吗？
就是每一个
你要的话，你这样子写跟那个正月是这样写。
那我这样写，我那样写也没有问题啊。就是没有，
是不是你刚刚说那个？
你刚刚说那
个
问题是你知不知道怎样从那边去，从这边去到那边吗？
懂啊？
啊？
去到哪边？
因为我那个 expression 啊，不是有那个，但是我一个方法就是讲，如果我把一个堆 term 有 x 的堆在一起，我可以 factor 出来，然后剩下都是没有 x 的。
但如果剩下都没有 x 了，你 y 那边的那个 coefficient 不是就没有 x 的 coefficient 了，就没有 x 的东西了。
没关系啊，
什么叫没有关系？
零也是在你的 Rxy 里面的。
我知道，但是就是说你可以更准确嘛，我就是如果真的没有关系了，你懂什么意思吗？就是你不是把 f(x, y) 写成 a0 加上let's say rxy x， 再加上其实你这个东西应该是没有 x 的吧？x 其实就是 py 了咯。
这个是一个办法去写它嘛，是我那个我可以不要这样 factor 也是可以的。
就看你会不会啊，就是
我把它写不是在循环定义吗？那你这样这边那个 RxY 也没定义吗？
是我猜
那把那 factorize 出来吧。
我猜两边的话，我两边
那我这个 RxY 不是还要做定义
？RxY 只是说来 function in x。哦，你是说？
那你本来的 f 不就是个 function in x 和 y 吗？
对哦，确实在数学角度写的很好笑啊，这样子啊，因为就是这个，
所以这是什么呀？
他只是想把 s factorize 出来吧。
我懂他是什么意思，问题是你这个写法
就没有什么意思。
这里是要 y 的呀，这里要是没有 y 的
东西
就含在 x 里面。
这个在 Rxy 里面的，然后这个是在，
我就觉得你这个
也是在 Rxy 里面。
他就想把 x 跟 y 拉出来吧。
但是我觉得这个定义很，
我没有定义，他只是来把它表示成这个形式吧。
我需要证明，但我也没有必要写成这样啊，因为如果我写成这样，
你就要这个东西先，其实。
因为我要证明啊，
证什么？
我要证明我 A polynomial 如果我写 general form 它存在于 kernel 里面，它这样它也存在于 generator 里面。
这个哪里可以成为
大师，你这是做新
就我刚写成那样的话，这样我 send 我的 fxy 是位于我的 R 里面的时候，它 evaluate xy 在0嘛。
I mean 你这个写法没有错，因为你做 division with remainder 就把这个写法写出来。 啊，有人要骂你了，有人骂你了，他叫你坐下去先。
到我了。
要注意他这个镜头。
Okay, so before we start, I still want to promote you guys to do the tutorial question. Please do tutorial question. I know this week you have less assignment, right? No deadline, right? What deadline you have? Huh? This week, I mean. Yeah, this week you don't have deadlines, right? So please start and do tutorial. Yeah, do assignment, also do tutorial. Okay, so please do tutorial. Otherwise, you tell me got deadline next week and then final come already. Okay, no time do. Please do tutorial. Okay, tutorial question. 潘星不知道有 tutorial 的存在吗？也要啊，都要奋斗啊，一起奋斗啊，很多事情要奋斗，好不好？Okay. So I think up to this stage, I think you should understand this poem already. 有没有人可以帮忙读一下这个东西啊？好像有一个人很喜欢念诗是吗？这个班里面啊，谁喜欢念诗啊？可以帮忙读一下吗？谁？报审批啊，有人只报审批，报审批帮我们读一下这个，有请你帮我们读一下。啊，没有了，就随便写一个吧，来读一读，不够大。
这可以来看到字。
Okay. Okay, so there's a English translation of this poem here. Actually, I took this poem from some online source, Chinese online source. Zihu, I think, maybe. Have you seen before or not? Huh? I mean, for the Chinese, have you seen before? Have you seen this poem before? Do you feel related? 就感觉到很亲切吗？ You feel related? Okay, so I want to discuss a bit on these poem. Whenever you see something when we say obviously true, okay, when I say obviously true or someone say obviously true, right? Usually it is a tedious checking only. Then you need to go through the calculation. You have to compute it. And if I say it's easy, make sure you know why is it easy. Okay, make sure you do all the calculation here. And then if the proof is left for exercise, at least for my class, actually I have done a similar proof already. Okay, so you need to try and figure out how to use what I taught you before. Okay, let's do it again. And lastly, last thing here. Okay, don't learn by method. Never learn by method. Okay, you must use definition. Okay, learn definition first. Only you learn method. Okay, otherwise you are lost in the method. You don't know why people do that. Okay, once you know definition, you will know why people do that. Add on, you can use your own method. Okay, as long as you solve the definition. OK 那这么反形这下，你做很多反应都有问题。Yeah. Okay. Yeah. So please learn by definition, not method. Okay. What else? Okay, last thing. So pure maths is about communicating. You have to always talk with your friend about the idea. Okay, if you keep to yourself, then it is zero. You learn nothing. Okay, you should always talk with your friend. Okay. Talk with your friend. OK， 有问题吗？上个礼拜last week，云溪 come and find me， 对吗？云溪，你来找我吗？上个礼拜是你不是 ？OK， 呀，对，上个礼拜他来找我，你知道为什么他来找我吗？找朋友，找朋友聊聊天。Yeah. So, Ying Xi asked a very good question. How to study pure maths? OK， 我跟你讲什么啊？有些我读学啊，这种定义，还有做题从不会到会。OK， 不会就去问别人。OK。先学习，然后再找自己的方法。OK， 我开始做吗？有，呀，慢慢来，慢慢来，慢慢做。OK， 不能一步登天，但是你一步一步，你肯定有一天会登天。对啊，特斯拉就是这样啊。特斯拉，你知道特斯拉吗？ You know Tesla? Chopstick. Have you heard about the chopstick story? Tesla, Elon Musk, there's a space rocket project. Okay, lastly, what he did is he can recycle the portion of the rocket. Okay, you know how long he failed this? He failed this for 9 years. He did it starting to 2014, if not wrong. There's a video about it. 2014, he failed. Until this year, 2023, he successfully captured the return rocket. Okay. 2024, sorry. Yeah, 2024. Okay. Yeah. Okay or not? So, yeah, don't give up. If your principle is correct, okay, then you will succeed in the end. If your principle is wrong, on the other hand, you will be punished one day. Even though you think you are successful, but you will be punished one day. Okay? Because in this world, there's a rule. There's a ruler in this world. You know who is the ruler? Big Bang. It is God. Okay. Tao Shen like to say one phrase, you know? Tao Shen. You know Tao Shen, right? Huh? Tao Shen always say one thing in our lecturer group. 你知道他讲什么吗？他说，我不知道他有没有拜神啊 ，but he said 举头三尺有神明。3 meters above you, there's a God. So there's someone watching you, so please don't be dodgy. Okay, so let's start. 啊，多 G 不？多 G 就是谁懂什么叫多 G？有人懂多 G 吗？摊平多 G 是什么？不讲。mention 啊？所以是？不是多 G 不是总多 Raisha, do you know what is 多 G？ 啊 ？Hey Siri, Hey Siri, got Siri or not？原来 Siri 跑到你那里去了。多 G 啊 ，what is 多 G？ 你们懂多 G？林恩多 G 会吗？不会。差不多是狡猾了呀，多 G。狡猾，躲机就是躲来躲去啊。dodgeball 啊，懂 dodgeball 吗？有人懂 dodgeball 吗？躲避球吗？躲来躲去啊，躲机，very 躲机，躲来躲去。Yeah. 另外一个就是狡猾了，其实狡猾。OK. Yeah. Okay, so let's pick up where we left last time. So last time we want to identify a coset in this ring. Okay, so how many cosets in this ring? So last time, how do we see this ring here? So this I here is not a random I, it's not random x. This is a I, that I squared to -1. Okay, but how to understand this? You can have an isomorphism between zi with zi quotient by x squared plus 1. Okay. Okay, recall that we have this isomorphism last time. If you don't remember, go and download the last lecture and see how we build the map. And then this is isomorphic to zx over x squared plus 1, comma, x minus 2. Okay. 中间的那个下面。This one is the image of x, the ideal x minus 2 inside the quotient ring. I mean under the image. Yeah, under the image. So what's this map here? This is the map that sends x to I. I to x, if you like. Okay, yeah, so make sure you revise this last lecture. Okay, last time we proved what? We proved that there's only 5 elements here. So how do we prove there's 5 elements here? Instead of killing x squared plus 1, first we kill x minus 2 first. And then only we kill x squared plus 1. Okay, the image of x squared plus 1. But killing x minus 2 means what? We can build a map that sends zx to z. Okay, so here there's a map x sending to 2. Okay, but in this case here, what we get is just modding out by 5. So we get F5. Later, we will introduce a more convenient language to talk about this. But what we do last time is we really build a map, very honest map. Okay, very honest map here. So I want to show you why there's only 5 things inside here. Okay, inside Zi, I minus 2 here. Let me show you what are the 5 things inside here. Well, so let's start. So let's start with this ring here. Let's look at it in this ring. So let's do the first step. So let's start with polynomial ring. ZX. Okay, so what's the definition of polynomial ring? I in C. What's the definition of polynomial ring? Find finite linear sum of 什么 finite linear combination of what? Sorry? AI x to the I such that AI live in where? Live in Z. Okay? Yeah. 就是 in x 的一些 polynomial. Okay? 它的 coefficient 活在 Z 里面. Okay? And then next step, what we quotient by first, let's say we quotient it by Zx over the ideal generated by S squared plus 1. Okay? What do you think is left here? What is left here? What is left here? What's left here? So my claim is what's left here is ax plus b such that ab in Z. Okay. Why? In this world, right? So in this world, what is the same? What are the same thing inside here? X squared plus 1 is equals to what? 0. Okay. Huh? 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 Oh, tomorrow. So how to understand this Zx over x squared plus 1? You should imagine what? There's a canonical map. Canonical map from where to where? From Zx to Zx. Multiplied by the ideal generated by x squared plus 1. So what's the kernel of pi here? Is the ideal generated by x squared plus 1. So who gets sent to 0 in this case here? S squared plus 1, one of them. And also multiple of s squared plus 1. So how do I get this? Actually, I use division by with remainder. Remember, everything that's multiple of x squared plus 1 is already equals to 0. Yeah. So these are the things that are not equal to 0. Okay. Okay. And then, what's the next thing you can do? So if we take a further quotient, right? So we quotient this ring by x minus 2. Okay, we quotient it by x minus 2. So what happened to these elements? So you can see that ax plus b bar, okay, is equals to a times x minus 2 plus a 2a plus b, everything bar. But in this case here, you send x minus 2 to 0, right? So this coset is equals to the coset of 2a plus b. Okay, but 2s plus b is what? It's just some integer. Okay, so you reduce everything to integer already. So what's my angle here? the angle here is I want to show that there's only 5 different integers here. Okay, this is my angle. I want to show that there's only 5 integer here. So how do I do this? How do I do this? If you can create 5 from this ideal, you are good. You create 5 from this 2 polynomial here. Is it possible or not? Because this is an ideal, right? You can take linear combination of the generators. Can you create 5 or not? Can you create a 5? 可以造出5嘛？用这个两个 polynomial， 想一想。I'll give you 1 minute. Can you create 5? Can you create 5 out of these 2? 不能啊，早晨，做不能。OK，他摇头，摇到很剧烈。讲一下怎样 create 5？高中题啊，讲一下。linear combination 嘛，对不对？乘也可以，都可以。linear combination 有没有5啊？在这个 ideal 里面？How to create 5？你算一下 x square plus 1 minus x minus 2 square. Can you compute this? Quite sure you can do it. 好像这个做工了哎，好像那挺好嘞，这个东西。啊？哦，看不到 ，sorry。为什么它这样呢？还是它只会这个颜色吧？它只会这个，算了。So if you compute this, you will get 4x minus 3。看得到5吗？在这边有看到5吗 ？Can you see 5 here? How to see Albert? 再来讲一次 equals what? Okay, so what should you introduce here? 4x plus 8 minus 8. And then, so you can group and this, right? Why we are good here? Because we can move this to the other side and become a linear combination of x minus 2 again. So you write 5 as a what? Linear combination of x minus 2 and x squared plus 1. Okay, so 5 actually live inside your ideal. So meaning what? Meaning you should further quotient 5 from your set. Okay, you should quotient 5 from your set. Then what? Then what's your set look like? How's your set looks like? So if you quotient out 5 here, so okay, so let's move everything back first. That's what happened, you got an extra 5 inside your ideal actually. Okay, so this one is equals to zx quotient by x squared plus 1, x minus 2, 5. So this is the technique when you do assignment question. If you found a number here and already mod is a coefficient ring is over z, then you can straight away mod 5 first. You can reduce the coefficient down to 5 things. Okay, so in the end, what do you get here? So what are the 5 coefficients here? Actually, it is just x squared plus 1, x minus 2, and then 1 plus x squared plus 1, x minus 2, and then 2 plus x squared plus 1, x minus 2, and then 3 plus x squared plus 1 x minus 2 and then 4 plus x squared plus 1 comma x minus 2. So really you just get the 5 things here. Okay? Yeah. Okay. So we reduce the integer set into 5 things. Okay? 有问题吗 ？Any question? 有问题吗？问题来，嘉玲。为什么是嘉玲哪一个东西？哦，退回来这边呢？为什么是 x 加 b 啊？为什么是 x 加 b？If you have a higher degree term, you can send it to the 0, 0, 0. Cannot say 0 now. Identity concept. Huh? Yes. Later we will introduce more on this. I mean, yeah. Yeah, 还有什么？还有什么要问？ Yeah. Okay. Let's try. Let's try what happened to s cube. Let's try what happened to s cube here. Can you rewrite s cube or not? In terms of x squared plus 1. You can write it as what? X times x squared plus 1 minus what? X. So meaning what? S cube and minus x live in the same concept. How 什么？周末啊，周末，我想一下，周末啊，讲跟你讲这个东西。Okay, so you see, so let me tell you, so okay, so if we rewrite this, s cube minus x is equals to x times x squared plus 1, meaning what? S cube minus x live in the ideal generated by x squared plus 1. Yeah, x. Oh, sorry, x, thank you. x. 然后我知道你少了什么东西了。这个东西有一点 this is actually the TFAE you see in the group theory. 记得吗 TFAE 那个两个相乘 okay, let me recall the analog thing in group theory. So group analog. Remember that you show that if a G hash inverse live in N, then G is living in the coset of H. 还记得 Ideal behave the same way. Yeah. Ideal behave the same way. Remember, we want to replace. Okay, we should prove it actually, but the proof is the same. 什么？会写法没？OK， 会写法的。但是好像可以 prove 到什么，还是要放这样子。好了。它如果在 hash inverse n 啊。hash OK。Yeah。OK 吗？有问题吗？这个 ？Later I will introduce. You will see it better 这个。现在有问题吗？现在暂时有问题吗？跑下去 OK。跑去哪里？但为什么这个50个东西是这个5个哈？Because we mod out by number 5 here. 对不对？你就要问我5跟谁一样 ？Belong to which? Yeah, 6 呢 ？Yeah, 7呢 ？Yeah. OK, yeah. 有问题吗？有问题吗？So one thing I want to remind everyone of you here. Remind everyone of you here is 现在哦，你们班的那个分歧，或者说你们的学习水平好像有一点被拉开，所以我希望成绩比较偏后的同学努力爬上来，不然的话你们这边会有分差。因为一开始的时候你们大家都很听话嘛，对不对？我也没有说你现在不听话啦，吧，就是说希望你可以更听话一点。就是说跟上我的脚步，或者跟上你同学的脚步 ，OK， 不然的话你们的班的那个水平会被拉开。所以说，也不是说你考得好不好的问题，这是我要讨论的是成熟度。我们讨论数学的成熟度啊，讨论数学度。如果你看庞星啊，你看庞星这个人不是，因为你这个例子太好了。因为如果你看庞星这个人啊，他之前在班上哦，他是懵的，甚至他在前2个 lecture 还要哭了。对 ，OK， 没有什么，很正常。但是现在你看到现在刚才那一刻为止哦，他不止没有哭，他还会问，而且问的东西还是在点上的。OK， 我希望你们成熟度被拉起来。昨天发生了一件事情，just yesterday there's one thing happening， 不是你们班的，我另外一个班 Calculus 2，他们恨我恨之入骨。OK， 为什么恨我呢？啊？哎，非常好，对，就不教方法，我摆明跟他对着干。我说他在我的 evaluation 说 teach more example so that I know how to do assignment question。我直接在班上讲不用，我就算教你做 assignment 的题，我 assignment 还是出另外一题。你懂我讲什么吗？我讲我出的题永远你是不懂怎样做的，为什么你永远不懂怎样做？康平，为什么你永远不会懂怎样做？为什么？懂方法，然后不会用，对不对？所以他学的是什么？他学的是题型。What he learned is just the type of question he can do. It's not about what the question asking. 你懂吗 ？You understand？ 但是昨天哦，他们听课的态度完全变了，你知道为什么吗？啊？谁生气？啊？
生你气
啊？
那个生你气的，
生我气？生气已经很久啊，生气应该是不要听啊，怎么生气还听呢？他不是生气，他的成熟度上来了。你知道为什么吗？发生什么事吗？昨天 ，Yesterday we had a presentation. Okay, calculus 2 presentation. I only give them 1 minute. They need to tell me what they know. And then we have a Q&A section. Q&A section I ask, they answer. I ask, they answer. 不止我问哦，还有他们同学之间问，自己对自己问。OK 吗 ？So 什么意思？他被问了过后，他就知道说 they know this knowledge。哦，要这样想的。Need to think like this way. Need to think like that way. It's not just I give you what to do. He all until then he will know. Oh, I need to consider this. I need to consider that. OK 吗？我不是要虐待你啊。I give hard assignment. I give hard question is not to torture you all. Okay, this is for yourself, for your own good, for my good also. Why for my good? 啊 ？No， 无聊啊！你知道你痛苦会发生什么事情吗？你会 fail 要发生什么事情吗？我要写 report 啊！你以为 ？You just see this abstract maths now you think it's very hard There are more things to learn, you know. Algebra, geometry, representation theory, Lie algebra, 这么多东西要学，你觉得这个天塌下来啊？不好意思哦，还有更大的天。来问一下这个，问一下伟哲，伟哲，你第一次学我的课的时候，是不是也是觉得很难？现在呢？还更难？对，很难，OK。但是你觉得有比第一次难吗？是不是？为什么你能学懂？你知道吗？你看过更难的东西啊，你的成熟度上来了，你看更广的东西了，你明白吗？因为你们太局限于自己啊，只看到自己天天。不过这个是很正常的，因为你就是跟你自己生活嘛。但是呢，you come here, you should learn more. You pay, you should learn. OK， pay 了不 learn 就浪费哦。OK，yeah， learn as much as you can. OK，OK 吗？Yeah， 但是要付出一点啊。That's all. OK，yeah。那个 agent 骂我啊，很久没有鸡汤了，所以给一个。来，嘉玲啊，这么是五？什么意思？为什么这个是五？Because I create the five out of these two elements. Because this is an ideal, right? So what's an ideal? Oh, can. You can make five first, and then you go and check out whether you can make 3, 4, or 5. I mean, yeah. Can you? Huh? Oh. Okay. Well. So one way to answer it is we use the other way to take the quotient, right? We found out it is F5. So naturally, we will go and find this 5 here. Another natural way is if you just look at these two polynomial, right? How do you gonna find number out of these two polynomial? Obviously, you want to get rid of the x square. Okay, after you get rid of the x square, you found that 5 is inside there. Okay, maybe there's a possibility, 有一个可能性. Maybe you can find 4, maybe you can find 3, maybe you can find 2, or even find 1. Then you need to prove it. Yeah, if you can find it. OK 吗？还有问题吗？ Finding 5 is from the intuition is from last time because we using the other root we found that it is S5. So we want to see from this root where is the F5? Where's the 5 from? Oh, the 5 is coming from the linear combination of these two polynomials. 谁在里面，谁不在里面？哪一个 number？ 1、2、3，这些 number， you can prove set 咯。你不是有做过 linear algebra 吗？ Set A B and then find A B 看看找不找得到那个 linear combination。 Yeah, you can do that. Yeah, if you want to prove that it cannot, I mean these 1, 2, 3, 4 cannot exist in this ideal, you just set A and B as a coefficient of x squared plus 1 and x minus 2, then you show that you cannot find A and B. Okay? Yeah. Okay, man. Okay, so before we take a break, I think I want to introduce a definition first. So, okay, I will make this whole process precise now. Okay, I will make it precise now. So let's define adjoining elements. So what it means by adjoining elements. So I told you what adjoin, right, last time. But now I'm gonna define it for you. So another way to see the coming definition is about this complex number, exactly what we did just now. But just now we just consider the Gaussian integer. So Gaussian, yeah. Gaussian, 什么问题？Gaussian。对啊 ，Zi 是 Gaussian integer Zi. So Zi is called a Gaussian 高顺，高顺 ，OK， 高顺 teacher， 高顺 teacher, okay, thank you. So, what is C here? C we can write it as R adjoin I such that I square plus 1. Yeah. So this can be done by the first isomorphism theorem here. So we talk about first isomorphism theorem, right? You need to tell me the surjective map. So what's the surjective map here? The surjective map here is really just send everything to Excel. Yeah. And then you show that the kernel is I square plus 1. The kernel is I square plus 1, right? Why? Because I told you I square equals to minus 1. So you will get I square plus 1 is 0. Okay. Yeah. So 你会看到其实很多 actually a lot of things you do, right, is like high school calculation. But now I will phrase it in math. Okay, this is one thing I need to discuss in your assignment 5 also later. Okay, yeah. All right, so if you don't like this I, right, we can make it more general. We can make it X. Okay, call it X also can. Okay, more generally. Okay, so let's define a ring that contains another ring as a subring is what we call the ring extension. Okay, ring extension. Do you know about extension? 应该很会吧？厦门学生应该很懂 extension 的，对吗？是不是带着那个 extension 带来带去读书啊？很多插头啊，来 extension 拿出来给我看 ，extension wire， 真是吗？你修了 extension。What does extension do？ 那个插头里面还有一个插头。So a ring that contains another ring as a subring is called a ring extension. Okay， 你不是插在另外一个插头上面吗？Okay, so let's give an example to ring extension and then we can take a break. So what things are called ring extension? Huh? Can you think of a ring that contains another ring as a subring or not? Kiss ring 啊？什么 ring？ R 里面有 Z, good. So R 里面有 Z. So we will say that ring, real number is a ring extension of Z. 还有吗？ Z 是个 ring 吗？是最简单的 ring. Yeah. Okay, anything else? What's a sub ring? What's a ring extension? 还有吗？再给几个？啊 ？R 到 C, yeah. So complex number is a ring extension of real. 还有吗？后面呢？后面有没有？有些有没有？啊，下一个。Matrix 可以啊？怎样的 matrix？ Invertible 2x2, so GL2 in real. OK， 你要 extend 它还是它是个 extension？ 这是不是 ring？ 是 ring 还是不是 ring 啊？如果不是 ring， 为什么不是 ring？ Is it ring? Okay. 为什么呢？为什么不 close? Why is it a ring or not? This one 很重要啊！我的考试第一题会考哦，只问你什么东西是 ring， 什么东西不是 ring。Is this a ring? Multiplication not commutative？ 还有吗？好像还有更简单的理由诶。加法不 close， 还有更简单的理由啊，好像。inverse 谁的 inverse？ 加法的 identity zero matrix is not inside here. So the additive identity is not in there. Okay. 啊？怎么不在嘞？为什么000不在里面 ？Why is it not in there? Determinant of zero matrix is 0. So not multiplicatively portable. 啊？为什么？好 ，Hello 阿丽，Hello 。哎，还能不能再给最后一个啊？最后一个，不然不会休息。你不要讲啊，禁言，其他人机会。Give one more ring extension。快点讲，快点讲。你讲啊，你讲讲看，你讲看，我就叫你讲嘛，你讲讲看。Z2 and Z4 how to put？ 谁是里面谁 contain 谁？跟我讲谁 contain 谁 ？Z4。哎，Adrian，谁 contain 谁？我们写出来，我们再 check。Z2在 Z4里面，对还是错？错，为什么错？为什么错？Z2 in Z4 why wrong？ 啊？谁什么 prime ZP 什么 ？OK，P 要真的没？我问你啊，真的啊？为什么？啊？没有啊，要有原因的嘛，对不对？So OK，so 正月生啊，ZP is a ring only for P prime。Why 啊？呀，有人不认同，所以一定要讲理由的，没有理由人家不信你啊。什么理由？有人知道吗？Why ZP is a ring only for P prime 啊？好像有讲过哦，check 哦。Why？ Because 谁是 ring？ 我就问他，我问他是还是不是啊？OK OK，想一下，放那个下课想一下。Let's come back at 6:06。我懂啊，他错你就要去破他。 他如果对就要证明
他骂你没有鸡汤了，我都骂你鸡汤太多了。我说他什么时候骂你这边都没鸡汤了，我都骂你鸡汤太多了。啊，对了，所以你那页想表达什么？
哎，
我翻译好。
点呢？我的这个保险。
为什么那个 linear combination 是 linear combination 吗？
啊，不知道你要讲什么？
我说如果是 linear combination，为什么那个 x 减2可以平方啊？
x 减2可以平方。哦，x 减2可以平方。
哦，因为你 x 减2也是那个 R 里面的东西。啊，
因为我们考虑的 linear combination 是那个 ring 本身，就整个 ring。
那对，那不应该只能
over 这个 ring。
是 over zx 不是 over z。
它不是 over z，它是 over zx。
啊
ideal 是从原本那个 ring 要拿出来。
因为他没做。
懂子没事。那个 ring 不是 z， 是这整个。
那这边为什么不能乘 x 呢？
哪里在哪里？
我们 a 不能是 x，那这里这个就是属于 z 了，那我们 a b 就属于 z 了，不是属于 zx。
那今天在 B1就图书馆。
哦，这是我定的。什么意思？我帮你讲。那就纯粹我写的罢了，跟你想的东西没有关联。
我说 a 这边的 a b 就只能属于 z， 但是这边 a b 这边又可以属于 zx。
哪里在哪里？
就是
只是说这里哈，你说这里哈，这里啊，这里哈，
因为我到的时候我是可以从 R 里面 zx 本式里面拿东西。
这个东西我要说，这个东西是活在这个z 这个 ideal generated by x minus 2 x squared 加1。但是现在你要问我的东西应该是这个 ideal 是什么？这个 ideal 是什么？这 ideal 是什么？怎样定义？
啊？
怎么定义的？
对，怎么定义 ideal 的定义咯
不是 fear。
close under addition close under multiplication 咯 multiplication by 什么呢？
那就不要听。
by ring element 嘛。那个 ring 是哪个 ring 呢？应该是它活着的那个 ring 嘛。这个东西活在哪个 ring？
这边我好像懂。
这个 ring 活在这个咯，所以 that's why 它的那个小 r， 还记得那个小 r 吗？小 r 是活在这边的。这个小 r 也是活在x 里面。So that's why 这个 coefficient 是活在 x 嘛。
我不懂了，
你不懂。
对，这边可以这样子。为什么这边为什么是你定义的？
我就证给你看咯。I mean 我其实也还没有证给你看，但是就是我大概讲给你听吧。等一下你会看到concretely 它是讲做出来。但是我讲给你听呢，我讲给你听的方式就是说，假设你有 higher power 的 degree polynomial，OK，then 你就可以用这个 x square 加1去 reduce 它的 degree。怎么 reduce 呢？你 reduce 过后除剩下来的 by division of remainder， 它的 remainder 是小于，它 degree 是小于2。
那如果比如说我 a 我觉得应该也可以是把 a 写成 x 方加1，然后它也是属于这个。
但是就是你还没有很精细，就是还没就还没有就把它写成不同的 concept 啊。这个是我已经把它写成 representative 了，我已经写成最简单的 representative。
我想，
因为如果你又放 x 进来的话，意思说你会重复写那个 representative。
对，
现在我已经是不同的 representative。
如果写进去 x 也是
可以的，
也是可以的，
因为比如就等于你把 s square 跟 x 写进来了，但没有意义啊！你这样写，你有写跟没写不是没差吗？因为反正你都把大家写进去了。当然我写的这个有差，是因为我已经把它分成不同的 representative， 就是不同的 concept。因为如果你那样子写，你可能会把 x cube 和 x 分开写，但是其实它们是一样的。
我好懂了。
OK。
有什么禁言？
就给人家机会讲啊，
我只是想快点下课而已。
不可能。
没有办法，你是活在这个世界上面。
我跟你讲，连3D 都讨厌，
讨厌什么？
就来
固执的人。我知道啊，
所以就他都没有办法，你觉得你有办法吗？也没有，
他可以拿个硫磺或者降个红石。
他降几次都还是这样。
那主要是想要给人自由意志，他不想要造群。
所以咯。哦，为什么 prime 是个是 feel 啊？
因为
prime 是什么先？
就每个东西都有 manipulate inverse，
不是每一个，
就是除了零，
所以
就我忘记了。
所以这个是那个
打数论
number theory 的东西。就是
我记得是可以写成
如果
那个
GCD
Euclidean algorithm，
xy 等于1的话 ，then there is this AB such that
x 加 by
加 by 等于1。对，
所以你就 like
a 和 x 就互 inverse 了，在 model。
如果你这个 mod y 的话
的情况下，
那就是 ax 等于1哦。所以 a 就是x 就是 invertible 在
我记得这个东西之后，后面是哦，所以就是 x 在 z mod y 里面的一个东西，然后 y 是 prime，所以 y 是 prime 的话，这样它和 x 之间其实就等于1吧？啊，所以就写成这个有给你 algorithm 给你的东西，就可以 mod y。
这个想好了吗？这个
这个啊，
我刚刚跟他们说，
这个不在这四里面哦，
对
他们2个人有交叉，只是
什么叫有交叉？
什么叫有
感觉有交叉吧？
没有，
你不仿一仿来想一下呢？
零的话，零
你不
八
仿来想一想，
什么叫仿？
不在这个里面，
哦，你能这么说吗？啊？
这么屌，
怎么可能？
不拿3在这里，这不在啊？
哦，我知道了，它的差别是在我想到这个东西，
那行，
想一下啊，这里面有
这个
谁？
对吧？这个应该对。
这个都不是 ring，怎么能 sub？哦，这是 subset，它不是 sub ring
确定它封不了人？
啊，是得是 ring。
加一下乘一下都是哦，对，他们都很 fail 哎，
ring 吧？
它是 ring，但是它不是 ring。
都很 fail。
也全部
这个东西对不对？
不对吧？
我在跟他们说这个地方的一跟这个地方的一不一样。
想一下，
这里的一，这里的一的话，这
这里的
零
零和这里的零也不一样。
对，
这才是重点。
哦，这里0是2n，这里是4n。
也
对啊，只是我们写都写成0818，它本质上不是总的，
所以哦，
所以我们不能说它是 subset，sub ring。
没有错。哎呀，我还没有点名。
这是我那天跟你说的那个 VP 的 ring。点吗？
你点得到没？
我会帮你喊。
不要让我听。我最近没有喊了，我大概知道谁了。
我可以喊。
天呐，谁可以帮我快速点？快速点名。
为什么感觉有时候你上课就像你在上 presentation，我在那边点评？
你点评我都没有叫这个。
转化完，然后
Hello。哎，对哦，我刚才没有电了，对。
那你觉得他现在就有变了？
好了，先用吧。Okay, so just now, so let's come back here. Z4 in Z2. Z2 is it Z2 in Z4 or not? Any relation between these two or not? If no, why? If no, why? How do you write Z2 actually? What's the element here? Actually, you can call it like 2Z plus 1, right? Z4 then? 4Z plus 1, 4Z plus 2, 4Z plus 3. Okay, obviously they are different set. Come on. Was that plus 2 leh? Okay, thank you. Okay, how about the other one? How about the statement given by Zheng Yue? True or false 啊？这个字，这个可能就会出现在考试了哦。That P is a ring only for P prime. True or false 啊？ True 啊 ？True， 意思说 Z4 is not a ring 了哦。Z4 not a ring 啊？真的咩？No. Okay, so if Z4 is a ring, how to prove? So if you want to like say that Z4 is a ring, right? So if Z4 is a ring, how to prove? Check all property, right? So what property? Abelian group? Okay, commutative, quite commute, right? Associative, very associative. Identity 0 ma, inside there. And then multiplication? Yes. Multiplication is more. Commutative, associative, identity 考试不是有考咩？是吗？考试不是考乘法 ，ZN 的乘法。Okay. And then distribute. Oh, I mean, it's true because Z distribute. So actually, this is a ring. Okay, but what's the true statement actually? That P is a what only for P prime? What's the true statement here? It's a field. Okay, so the true statement here is that P is a field for P prime. Why? Because of this number theory facts here. Okay, if the GCD of two number is 1, then there exists two number is Z such that the linear combination of X and Y equals to 1. But if you take mod Y here, what do you see? You see something multiplied to X equals to 1, meaning what? X has a multiplicative inverse. This is true. X has a multiplicative inverse only when the GCD of X and Y is 1. This happens when P is prime. If P is prime, then every other non-zero number with P, the GCD is 1. Because the only number that divide prime is prime and 1. If you are not prime, then you don't share the common factor greater than 1. Okay? 讲哪一个？讲哪一个？讲哪一段？ If GCD of two number equals to 1, then there exists AB in Z such that the linear combination of X and Y in terms of AB is 1. Okay, if you take mod Y, you will get what? AX equals to 1. But what does this say? This says that X has a multiplicative inverse. So if Y is prime, meaning what? Who is coprime to P? Who is coprime to Y then? Any number that is not Y and not 1. A1 also coprime. 1 is always coprime. Okay? Okay. Okay, next. So last time I defined Rx, I told you is adjoint, right? So now let's define properly. We'll say that an element alpha is adjoint. Adjoint. Okay, adjoint. Adjoint to a ring R if what? If there's a ring extension. Okay, so what's this ring extension here? This is R alpha. R adjoint alpha. Okay, such that this ring is isomorphic to Rx quotient by a polynomial F. Okay, so we define an alpha is adjoint to a ring R if this new ring extension here. So how do we see this as a ring extension? So this is an extension of what? Of obviously of R. Okay. And what is this R alpha here? R adjoint alpha here? This thing is isomorphic to Rx. But quotient by the ideal generated by F. So what's the relation between alpha and F? What do you think? What's the relation here? Maybe you should guess. So where alpha is the root of F, okay, with F in Rx. Okay. But this root here not necessarily live inside R. I'll give you an example in a moment. I'll give you an example in a moment. So for example, so let's give you an example. This example, you have seen it before already. For example, C. Okay. So how do we call this complex number here? We'll say that this C is equals to the ring extension that we call R adjoint I. Okay, what's this R adjoint I here? This is isomorphic to Rx quotient by x squared plus 1 here. Yeah. Oh yeah, real. This is a real number. Okay. Real number. Real number. Is that real number? Real number. Huh? Why is that a real number? So well, what is complex number? Complex number. 我讲哪一个? Oh, sorry. Sorry, 我看错东西. Yeah. Okay, thank you. So, how to see this? How to see this isomorphism here? So you can see that I is the root of x squared plus 1 here. Is it the root of x squared plus 1? Yes. You know how to check? Sub, right? So if you can square I square plus 1 equals to 0. Or sometimes you will see that people write x squared equals to minus 1. Okay. So whenever you see this kind of quotient ring, it is always isomorphic to the ring adjoint the if this function is irreducible. If it is irreducible, you can find this isomorphism. If not, you cannot. Okay. Okay. So another example I gave in the textbook, given in the textbook is we can always adjoin and inverse of A to R. Okay, let's say this A is living inside R. Okay, so how do we do it? So we can consider the ring R prime such that Rx multiplied by Ax plus minus 1. Okay. Okay, ma. Any question? 原题吗? So by doing this, right, what do you see here? This x here is a how do we call this? It's a variable. Okay, it's a variable that you multiply to a, you get 1. So I adjoin the inverse of the ring R. Okay. Yeah, maybe you will see more example later. Okay, so far any question or not? So far any question? So I define what is called the element adjoint to a ring. or R adjoin alpha. Okay, so how do you think about adjoining this alpha? You should go and find a function that get this isomorphism. Okay, so let's continue first. We can come back if you have any question. So next question is let R be a ring. 什么问题？有问题吗？怎么关心干嘛？哦 yeah, sure. Adjoin is an extension. Extension of what? If R adjoin alpha, meaning it's an extension of R because you must and R inside. The extension of R. Inverse 是什么意思 I mean, it's just adding inverse of A into your ring. Yeah. I mean, 如果真的要写的话，就 R adjoin, let's say A inverse or like that. 减一等于零，一减一等于零，一减一等于零，一减一等于零，什么关系啊？有什么问题？Oh, okay. So what's this map here? This map is sending x to A inverse. Okay, and then you show that it's an isomorphism. Okay, so you need to check that the kernel is ax minus 1 generated by ax minus 1. Okay, and then you check that kernel of phi is equals to the ideal of ax minus 1. And then obviously you need to check. So here check phi is surjective. And then you can use first isomorphism theorem. Okay. Yeah. So here is really a polynomial ring to remind you. This is really the polynomial ring. Polynomial. Okay. Okay. So let's do it in more general. So let R be a ring and let fx be a monic polynomial of positive degree n. Okay. With coefficient in R, so over R. Okay, over R. And then let R adjoin alpha. Okay. So denote the ring R. So R adjoin X mod up by the polynomial, the ideal generated by polynomial F. So how do we do this? Simply we just adjoin. Okay, adjoin an element that satisfy. So satisfying the relation F alpha equals 0. So there's a subtlety here. Maybe if you are really an algebraic person, maybe you should ask why R adjoin I and R adjoin X is different. They are just polynomial ring, right? Why are they different? Actually, when you look at R adjoin I, right, you have an extra condition in your mind, which is I squared equals to minus 1. Okay, so when we adjoin things into the ring, right, you need to ask yourself whether this variable here satisfies extra property. Okay, if it's satisfies extra property, maybe you can write it as a quotient ring. Okay, if it satisfies extra property. you can write it as a quotient. Okay. Otherwise, it's just a normal polynomial ring. Okay. Then, first thing first. We will say that we will say what? The set 1 alpha up to alpha n minus 1 is a, so don't put this where's this set here, is a basis of R adjoint alpha over R. Okay. Basis means what? Basis means what? What is the use of basis? Do you know? 哪一种吗？简化。how to 简化？ Meaning what? Every element in R alpha can be written uniquely. Uniquely as what? As a linear combination. Okay, good. Linear combination of the basis element. Yeah. 对 ，linear algebra 很好用啊。You cannot forget. Okay. Over R. B, what can we do here? So we have basis, right? So we kind of want to build a vector space. Okay, we kind of want to build a vector space here. So what's the vector space here? So we can add two linear combination of the basis element. So how do we add? How do we add? How do we add? Just factor addition. Okay, I just add out the coefficient in the same degree. Okay, yeah. So where's the similarity here? Here you should relate back to your polynomial ring. Okay, you should relate back to your polynomial ring. But in polynomial ring, the basis is infinite. But now the basis is just 1 alpha out to alpha n minus 1. Why alpha n minus 1? Where is alpha n? 1. Come on, 1. Remember, where's this n come from? Where's this extra condition of n come from? It comes from the f. What's this f? F has a positive degree n. So you should imagine that this f is something like x to the n plus maybe, let's say 2x minus 1 or blah, blah, blah to maybe 1. Okay. It's monic, so Sn has the leading coefficient is 1. So, but in this adjoint ring here, right, f alpha is 0. So if you plug alpha into this polynomial, you will get 0. So you can replace alpha n in the linear combination of monomial in smaller degree. Okay. 对吗？对吧？是不是？对吗？ Okay, later I give you an example. Okay, maybe I give you an example now. I don't want to talk about C later. You don't know how to imagine. So let's give you an example. And we won't prove this proposition. It's a right routine word to do. So let's take R equals to R. And then let's say we take fx as a monic polynomial of degree 2, x squared plus 1. And then alpha equals to 1. Again, the complex number. Okay, so let's see. The first claim is saying that 1 and I will form a basis in R adjoint I. Is it true? Is it true? Is it form a basis? How do we describe R join I? All the element here is A plus BI such that I square equals to -1. Okay. Why? Why there's no such thing like A plus BI plus I square? Because I square is already -1. Okay, so you reduce every higher degree than 2 to either constant or I. Okay, to the term containing I. Okay, so you can write it as a linear combination of smaller degree of I. In this case is degree 2 because your monic polynomial here is degree 2. Okay, yeah. And then B, for example, if you want to add two such number together, what do? Let's say A plus BI plus C plus DI. How do? You just A plus C and then plus B plus D times I. Okay, yeah, that's all. Multiplication, can you do multiplication or not? A plus BI times C plus DI. How do you do this multiplication? AC minus BD plus AD plus BC I. You memorize or you compute? Oh, you compute. Okay, very good. So for example, let's say if we what? So let's say I don't want to compute here. I want to compute it in Rx before modding out. Before modding out by S squared plus 1. Can I do computation in Rx first? Okay, so let's do computation in Rx. Because there's isomorphism, right? Okay, I can look at the computation in Rx first. So A plus Bx times C plus Dx. What is this? AC plus AD plus BCX plus BDX squared. Okay? Yeah. So you see, okay, you got AD plus BC, but you see, these two AC and BDX squared got split up. Okay, so this is in the world of R adjoin X. But now you are quotienting out X squared plus 1. Meaning what? Up to X squared plus 1, they live in the same process. Okay. So you can see what? What can you see here? BD. Add the BD. Minus the BD. Add the BD minus the BD. Oh, add the BD minus the BD. Okay, good. So add the BD minus the BD. Okay, good. So AC minus BD plus AD plus BC X. And then plus a BD plus a BDX squared. Why? Why 1000 want to do this? Because we want to create a multiple of X squared plus 1. Okay. But this thing is equals to what? AC minus BD plus AD plus BCX. We can write it as like mod the ideal generator X squared plus 1. Okay. Yeah. Okay. So this is like a generalization of modular arithmetic. Okay. Right. Generalization of modular arithmetic. Okay. Yeah. So maybe I put this sign here. Okay. Okay. Not any question? Okay. So I left the multiplication statement to you. So try and write down the multiplication here. So how to define? Okay. Right. Let's see what else to do here. What time? 6:30. Okay, maybe we give another example and then we can take a break. No, take a break. Discuss a quiz. Discuss assignment. Okay, let's look at this example here. Hey, someone told me these three have to put at the top, huh? Okay. I took at the bottom for 30 years. Okay, so what's this kernel? What's this kernel here? 来，前面几节的东西。What's the kernel of this map? X power 3 minus 2. Okay, so you should be able to prove this now. And then, so in this case here, is this map subjective or not? Not subjective or not subjective. Right, so what can we do here? 这 C 有用吗 ？C 感觉很没有用。这 C 好像好大啊。C 不是很有用。So, well, I mean, we don't want to consider this C 为什么要写出来啊？忘记了。So if I reduce this size, we can show that Z alpha, okay, Z gamma is isomorphic to ZX over minus 2. Okay. Okay, why can I write this? Why can I write this? Obviously, this is subjective now. Okay, so well, instead of talking about C, maybe we just talk about Z adjoining gamma here. Okay. Okay, so in this case here, what is the basis? Okay, what is the? Let me ask you a question. So the question is, write down basis for Z gamma. Okay, so how to write down a basis for gamma? So Z gamma here. So what are the elements inside here? You need to ask yourself, what's the element inside Z alpha here? Z gamma here. This is a linear combination of let's say AI to gamma to the I. So I from 0 to n, let's say. Okay. Okay. So for example, what kind of elements is inside here? Maybe x to the 4 plus 1. Sorry, gamma to the 4 plus 1. Does it really exist or not? No, 不知道。天哪，就是选一个吧 ，example， 对不对 ？Okay. But can I reduce this element or not? Can I reduce this element? When I write this isomorphism down, what it means? The gamma here will be the root of the function that you portion up. So meaning this gamma here will satisfy what? So this gamma here will satisfy gamma cube minus 2 equals to 0. Okay, because when you portion x cube minus 2 out means what? X cube minus 2 is the same coset as the 0 coset. Okay, so they are same is 0. So meaning what? Can you further reduce gamma to the 4 plus 1 here? How to reduce that? How to reduce? You know s cube minus 2 is equal to 0. So can you reduce s to the power 4 plus 1? So you can write x gamma gamma 4 as what? Gamma times gamma cube plus 1, which is equals to 2 gamma plus 1. Okay. So if the function that the polynomial that you portion out has degree 3, you can reduce every element to degree less than 3. So in this case here, what's the basis? What's left here? What are the things that left here? You can write it as a linear combination of 1 gamma and gamma square. Because if you have gamma cube, what happened to gamma cube? You make it into 2. Okay. So it's a basis for Z adjoin gamma here. So we will call it a Z basis in this case because my coefficient live in Z. Okay, maybe I'll let you try one thing first. So, okay, everyone take your pen out. So try and compute what is beta 1, beta 2, where beta 1 is beta 1, beta 2, such that where beta 1 equals to gamma square minus gamma, and beta 2 equals to gamma square plus 1. Okay, try and compute this. I'll give you an idea how to compute this. Let's try and do this computation. Okay, maybe I write down the relation for you so that you remember. So this is r cubed minus 2 equals 0. Okay, yeah, I'll try and compute this. Right, to see that really every element can be written as a linear combination of 1 gamma and gamma square, such that the square there is coming from the degree less than 3. Yeah, try and compute this. 乘一乘，看一下。来，等下中一方告诉我什么答案呢子豪在吗？子豪，陈子豪。哎，子豪中午没有在啊？什么？失眠？哦，OK。好。金星还没有回答。赵瑞，赵瑞，他功课还没有交啊？还没有。你可以叫他交一下，再找回他自己哦。金鹏呢？刘金鹏没有来啊？没来，他跑到哪里去了？OK，算出来吗？一凡，怎么？干嘛？平方加干嘛？减一减一啊？你可以给我第一行吗？第一行是什么？嗯嗯。 多少？哦，我知道，我不是说那一行，就是打开了过后，distribute 过后，distribute 的第一行是什么？嗯哼，OK，good，减伽马，OK，然后你怎么拿到这个答案？对，对对对，讲错，没有错，OK OK，加伽马，对，啊减二啊，OK 减二，good。So this way is using substitution 哦，OK。Anyone using division by remainder 啊 ？Division with remainder 有人用吗？Long division 算是 long division，有人用吗？你用哈，你怎样用？来算一个给我们看。等一下，你等我一下。We also start with gamma 4 minus gamma cube plus gamma square minus gamma, right? So 你怎样用？What do you do 啊？啊？可以这样做，但是它是可以写成乘法的那个东西。Long division you can write as a multiplication 啊，然后 OK yes this one what do you compute to? You should also compute to gamma square plus gamma minus 2. Yeah, yes, right. That's right. That's right. That's right. Okay. Remember last time we proved that the long division is equal to the substitution and the remainder. Okay. Yeah. So these are two different ways to see this solution. This is using a division with remainder. So how do you understand this? You build the zero, okay, out of this polynomial here. You build the zero, and then what's left here is degree less than 3. Polynomial degree less than 3. Okay, any question? 问题吗? Okay, so before we break off, let's discuss the assignment. Okay, so there are only 3 questions in assignment 5. I think you all know how to show normal subgroup already. Pretty good. But just that when you say that a subgroup is not a normal subgroup, you need to tell me why. Most of you didn't tell me why the element that the conjugate that you compute is not living inside the group. You need to tell me, okay, why it is possible to not live inside the group. And then the hard part about the first question is to see that the quotient group is isomorphic to what? Multiplicative real number. Okay, non-zero real number here. So only 2 groups are normal, actually B and C. Some of you say that all of them are not normal. 这样我题目不是出得很亏？这样我题目不出很亏？如果都不 normal， 我还加这进来干嘛？对不对？而且分数又给这样高，你不奇怪不怀疑一下？相信我。Okay. So only B and C is not normal. Sorry, B and C is normal. Then you need to choose the right coset and then build the map. And actually, some of you didn't find this coset also. 有些人没有找 coset 也可以做得出哦，很厉害哦。为什么呢？ Because what you really need to show is if you build a map from the quotient group, okay, to R cross here, what you need to prove here? How to show isomorphism here? what you really need to show is you need to show that the kernel of this, let's say this is another phi. This phi is the S. That's all. 就这样吧. Okay, that's all you need to show. Okay, some of you didn't choose the nice representations, but you managed to show this kernel. Good. Okay, also good. Any question? You want to? Yeah. This way is good. This way is good. Why is it good? Why is it good? Because you don't need to compute the concept. You don't need to compute the representative. But the way I taught most of you is you go and find a representative to make your life easier in the kernel when you show kernel. When you show kernel, yeah. Yeah, different life get difficult in different place. Okay, yeah. And question 2 actually, you guys, all of you get it, but一凡写了这个东西啊，不是你，是钟一凡 ，sorry， 钟一凡写了这个东西，这东西看起来很犯罪，这东西很犯罪，你知道为什么犯罪吗？为什么哈？我告诉你，其实哈 ，x cube equals to y square 的意思是什么？3个 x 乘起来等于2个 y 乘起来，所以我看不出3/2y 在哪里。2/2y。OK， 可以吗？所以为什么你们高中会这样写啊？你有没有想过这个问题？老师教的。为什么会高中时候可以这样子写啊？其实，一个 one of them is real number, the other thing is what? You are trying to solve what? You have to solve. Yeah, you solve for x. You are trying to solve for x. 但是我们这边 is just a group element， 东西乘在一起吧。Yeah， 我们没有什么 root 在这里。Yeah，OK， 所以不可以写这样的东西出来。这会写啊。Okay, please don't write this kind of thing. Okay， 你再制造一个新的东西出来了。Yeah， 这个东西不知道是什么来的。Yeah，OK， 因为我们的 group 里面只有 x 跟 y 现在，然后我们可以互乘吧，就是这样。OK。Oh, another thing is I asked you to research on this conjecture, right? Anyone research this conjecture or not? 看不懂 Okay, good. 来，我们来讲讲看他在讲什么。So the conjecture says what? Yeah. So yeah, cool. Yeah, that's right. So okay. 我先讲 statement 出来，然后我再解释里面的字是什么。Okay. So the statement says what? 把这个弄小一点，还是把它丢掉。Okay, what does the conjecture says? So 我画起来啊。Any balanced presentation of the trivial group can be reduced to the trivial presentation using a set of specific move. Okay, so what does the balanced presentation means? Balance 的概念 is what? 玩过叫什么？跷跷板。Seesaw 是叫 seesaw 吗 ？Seesaw, have you played seesaw before? Balance. Two sides must be balanced. So where's the two side here? So one side is generator, the other side is relation. Okay, so let's check if we have a balanced presentation or not. You see, on the generator side, how many generators here? 2. On the relation, how many relation? 2. Okay, so Andrew's conjecture says that any balanced presentation of the trivial group can be reduced to the trivial presentation using a set of specific move. So meaning what? Meaning you can reduce the relation and reduce the generators to just the identity element. Okay, this is the conjecture. 好像到现在还没有被 prove 过。But you learn try to attack 这个 conjecture 吧。 Try to attach this conjecture using a different language, and maybe in graph theory something. 用不同的 language 去 attack 它。就是 conjecture 不是 conjecture 是还没有证明觉得对的东西。No， 都没有被证过。
它有可能是错。
对，除非你有一个 counter example 啊，你可以拿 counter example 的。哎，有啊，有人哦，有啊。刚刚看 conjecture， 哦，没有 ，sorry， 没有，他们是猜觉得是，但是又不是。Rule of that form are conjecture with the counter example to the Andrew Curtis conjecture, but this problem is still open. 还没有 prove 到，他觉得是，但是不知道是不是。Yeah. Okay. I think most of you get 20 marks from here. 全部人都 OK。最后一个是比较 disaster 一点。OK, last one。最后一个。OK， 为什么这样长啊？其实为什么这样长？我有一个原因，就是我 show when I show injectivity, there are two different ways here. First way, I show it by the what you write of product writing argument. Show the 6 things inside there. But the second way here, I what do I do? What do I do here? Yeah. I also rewrite the product also. So in both way, I rewrite the product. One thing I want to comment on your solution is some of you just write this. So you write this. So you write x equals to 1, 2, x equals y equals to 1, 2, 3. And then you check that all these relation will be satisfied. Okay? Yeah. So in this question here, I want you to build map and then show isomorphism. Okay? Actually, it's not 没有错到很离谱啊，如果你这样写的话，但是我不知道你知不知道你自己在写什么？我不知道你知不知道自己在写什么？如果你写成这样的话 ，actually you are building a map from X to S3. I mean, sorry, from this group presentation to S3. Okay, yeah. And then after you check the relation, you just show that the normal subgroup generated by this relation is living inside the kernel of the homomorphism. Okay, but the problem here, the key problem here is how you know that if you form this map, the kernel is exactly equal to the normal subgroup generated by this relation. Okay, this is the problem, main problem here. So how do I come across this problem? Is I just directly check on every element. 我直接在每一个 element 上面 check. They should send to different things. Luckily, I can do this in this case. Why am I lucky? Because this set is fine. There are only 6 things to check. So this reduced to a question that can I reduce the set to 6 elements or not? If I can, then I just check that this map sends 6 elements to different 6 elements. So it's an injective surjective match. Okay. Okay. 有问题吗？有问题吗？就有问题。You look at your solution. Okay, you look at your solution, and then you look at my comment, and then if you don't understand, you can ask. 看下你的答案，看下我改的东西，看下你懂我在改什么。Actually, every time I release the solution, please read my solution. 可能你答案是对的，你看下别人怎么写，看下我怎么写，看下能不能写到更简短一点。Okay, so 为什么这题答案这么长呢 ？Actually, there are a few things you need to check. First thing, you build a map. Second, checks comment subjectivity. Third, comment injectivity. Commenting injectivity is the main point of this question. Okay, either you can show that the kernel is the normal subgroup generated by this relation, or You check on the elements. Check the map of elements. All of them get sent to different places. That's all. Okay. So basically, if you can write out this kind of argument, I think I mostly give you at least 10 marks, half of the marks. Okay, at least you know how to go between group presentation and S3. And then the other 10 marks were left for this technicality here. How you fill out all the main point. Okay, yeah. Okay. So this time round, got some swapping. I think Raisha got 60 in this assignment. And then we have 57, 58 for Adrian, 嘉玲, 陈嘉玲做得挺好的是 ，Yeah， 有用心做吗？有没有用心做？是不是？真的，我有学生告诉我，老师你的 assignment 我做到头发都掉完了，没有掉完了，还是开玩笑吧，掉头发。还有正月啊，还有正月。我 P 的时候有没有掉头发 ？OK， 有问题吗 ？Any question? Actually, I got one question. Rachel, last time you are not here. So we are talking about your assignment last time. So you do my assignment like a project, right? But I got one question. Why only treat one question like that? Oh.
Using pictures more not.
Okay.
It's not more.
Okay. But something I noticed across your assignment, right? There's only one question you choose to like write it in very detail. Very tiny. I thought you are Superman. Okay, good. Okay, very good. 一点了。Okay, any more? Okay, I'll see you on next week. Last week. Good luck.
I 真，我之前有想过针对题的。